Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
In the previous video tutorial, we looked at comparing the LandSat and the Sentinel classification images with one another, both via the overall statistic and via the images themselves. So although the statistic shows indicated quite large differences between LandSat, Sentinel versus the standard classification and random forest classification methods, visually it was a little bit difficult to see it from looking at the whole region of interest. So as I said in the previous video, we're going to create a split screen where we can, I think, easily identify visually the differences between the classifications from LandSat to Sentinel, from the standard method to the random forest method. Okay, so we've done that. So there is the code. Okay, so nothing new to what we've done in the previous tutorial. We've got all our classes or our categories of features, and the ROIs or training samples for each of those classes or training or features. Okay, now remember, when we do split screen, disable all layers that in general you would add to the map. So the ROI layer and all those layers must be disabled. Only the two layers that will be presented in the map or in the split screen must be activated. All other layers must be deactivated. Okay, so just remember that. Then we've got our standard code to generate our LandSat 8, LandSat 9, Sentinel 2019, Sentinel 2013 images. You see, I have disabled all my layers. Okay, so disable each and every single layer. We've got our standard bands, and then again, similar to the previous video tutorial, I'm only going to focus on the 2023 period. Okay, so I'm disabling LandSat 8 and my Sentinel 1 image, which both refer to the 2019 period. So I'm only looking at 2023, but again, that is up to your discretion. You're welcome to use them interchangeable. Okay, my training stays exactly the same, nothing different. I'm using the same ROIs or the same training samples for both classifications. I don't have separate ROIs or separate training classes for LandSat and for Sentinel. I use exactly the same ROIs. Now the ROIs are these 50 water feature points, the 58 vegetation points, the 58. Those are what I will refer to as the ROIs or your training samples. Okay, remember that they are what we refer to. Okay, these are my classes or my feature categories. Okay, and each class or feature category has a number of ROIs or training samples. Okay, now this is where the big difference comes from the previous one. I now have to create a LandSat 9 training input and a Sentinel 2. Remember, Sentinel 2 only refers to the period 2023. So if I were to have a LandSat 8, I want to do that, I have to create a training input for the LandSat 8 as well. If I want to create use Sentinel 2019, I have to create a Sentinel 1 training input. So now I have to have one for each of my data sets. So if I want to do LandSat 8, 9, meaning LandSat 2019 and 23, and Sentinel 2019 and Sentinel 2023, I need to have 4 training inputs. Okay, so that's quite important, and you make sure that you are giving them unique numbers so that there's no overlap. No two variables can have the same number. Okay, and that would be the same for my training. You can see again LandSat 9 training and prediction variable, and a Sentinel 2 Now remember, Sentinel-2 doesn't refer to a separate Sentinel and Sentinel-1. It's the time frame, but okay, it's a reference. So Sentinel-2 training and prediction variable. Okay, so if I were to do LandSat 8 for 2019, I will have one for that. And if I'm going to use LandSat for 2019, I'll do that for one. Okay, so then I'll have 4 of these pieces of code, each called, each given, each variable given its unique identifier or its unique variable name. Okay, so yeah, so there's that. And then you've just followed through. So now you'll see there I have, now I've created 4 variables here, 4 classification variables. And the reason why I've created 4 is because I'm working with 2 methods of classification. I'm using the standard method and the random forest method. Okay, so this is my LandSat 2019 or LandSat 2023 or LandSat 9 classification based on the standard training standard classification method. Okay, and there's my Sentinel. Okay, also 2023 for my standard classification method. Okay, you can see there LandSat Sentinel, LandSat Sentinel, and here is a duplicate of the first one, but with a random forest classification method. And I'm using 10 trees because remember in the previous video we sort of alluded to the fact that having less trees gives better classification than having more trees. So agreeing with that sort of analysis, I've decided to use 10 trees, not the 100 trees. And here I've got the LandSat for the random forest and the Sentinel for the random forest, but they both use the same LandSat images and the same Sentinel images. Remember, the same bands. Remember, LandSat use the LandSat bands, okay, LandSat and Sentinel use the Sentinel bands. So remember to make sure that when you write these codes, you have the correct variables for the correct calculations or equations. Okay, so please make sure of that. Then because I've got 4 classifiers, okay, I'm going to have 4 classifications. Okay, so these are my classifiers and these are my classifications. I've got a LandSat 2023 classification based on the standard, and I've used the abbreviation STD. Okay, so STD stands for standard classification. Okay, and then I've used RDF for random forest classification. Okay, so I've got a classified image for LandSat using the standard method, which is based on the LandSat 2023 image, median image, sorry. Then I've got a classified image for Sentinel based on the standard method, okay, which uses the Sentinel 2 or the 2023 medium image and so forth. My land cover is exactly the same. And then I've added these, and then I can add these 4 images to the but remember, we're not going to add them, so we disable them. We're only going to add them when we don't do a split screen, okay, or split map. In our case, we disable it because we're not going to display it. Okay, but if for whatever reason you want to display all 4 of them, just deactivate the split screen, meaning this part here, deactivate it, and then activate the map add layers, and voila. All 4 of those images will be loaded in the maps. Okay, there's our matrix to calculate the overall accuracy of my LandSat 2023 standard classification image. Okay, that's what that means. Then I've got also a matrix for my Sentinel standard image for 2023. Then I've got my LandSat image for the random forest 2023, and I've got my Sentinel image based on the random forest classification managed for 2023. So I'm calculating all 4 images. Where I did that in the previous video tutorial separately, I do them now all at once. And then obviously I'm going to split screen, where I have, in this case, I'm using my LandSat standard classification, as my one screen or one part of the screen, and I use my Sentinel standard classification as my other part. Remember, the one that I present first, that's on your left hand side, and the one that you present to, which is all called map 2, will be on your right hand side and will be displayed in your screen on your layers panel. So this one, the first part of the map, won't be displayed in your layers panel, only the second one, and the second one is on your right hand side and the first part is on your left hand side. So here I'm displaying. So if I want to display the random forest, I will just change this to RDF, the random forest classification, and I'll change the name. But you actually don't need to change the name per se, but that's what you do. Okay, and then we just split the screen and we center the screen, etc., etc. So standard stuff that we used previously. Okay, and remember to save and to run, to save and to run. Okay, so let's quickly make that. Okay, so I have run the code and the script, and there is my split screen. Remember on the left hand side. Okay, let's first go through the, before I go there, remember, let's first go for the over accuracy. Remember, this is 37. Remember, the 74 is the accuracy of the LandSat classification using the standard method classification for 2023. Okay, so that is LandSat standard classification. This is Sentinel standard classification. Almost 100% accuracy according to this calculation, or to the Earth engine. Big change. So Sentinel using the standard classification by far superior than the standard classification. And the reason, because of the difference between our numbers previously, I think we had a 94%, was just, remember in the previous video we had 100 trees, now we only have 10 trees. Okay, so those are the first two. Then the second two, or the last two, 78%. Let's make it bigger so it's all in one screen. There we go. Okay, there is the 78, which is LandSat using the random forest, and this is Sentinel using the random forest. And the same as previous video tutorial, or same as a previous outcome, we can clearly see that the random forest improves the accuracy using LandSat, but the accuracy decreases when using Sentinel. But in all cases, the Sentinel outperforms the LandSat. So in this case, the Sentinel standard classification is by far, according to this, the most accurate classification. Okay, so that is what the statistics tell us. So in practice or visually, let's see the difference. Okay, remember, we're going to first look at the standard classification. Remember, left, LandSat, right, Sentinel. Okay, and you can see the difference. You can see that in LandSat, on the left hand side now, and Sentinel on your right hand side. You can see the big difference lies in the sand, bare soil, which is pink. You can see Sentinel, if you look at now at this part of the screen, much more bare sand than if you look at the LandSat. LandSat indicates those areas as vegetation, where Sentinel indicates a lot of that areas as either bare soil or agriculture. So there's definitely some differences there. You can also see in the mountains, if you go to LandSat, it indicates the mountains at a much bigger scale than if you go to Sentinel, which indicates the vegetation on the mountains. And then obviously it is the amount of urban areas. You can see Sentinel, quite a bit of urban areas there. LandSat, very little urban areas there. Now, and you can see there the differences as well. Now, which one is, remember, according to the statistic, the Sentinel, this one here, is more accurate than the LandSat one. Now, to actually put this in perspective from this side, it's very difficult. So let's drill into a specific area, And then let's have a look at that. So I'm drilling into this specific area, and I'm going to open my satellite. Remember, I can use my satellite map here, because the satellite map most probably is the same period as the LandSat 9 and my Sentinel 2023. I won't be able to do this with LandSat 5, for example, or even Sentinel 2019, because it's most probably not going to be very efficient. Okay, so let's quickly just wait. It's slowly but surely loading. It does take a bit of time to load. So remember, you can do this for the random forest options as well. Okay, so let's have a look. We know this is a urban area there. Let's put on the map. Why is the map? Okay, you can see there's the urban area there. Okay, the satellite. Okay, so let's quickly have, so see that area is urban. You can see it's giving it as bare soil to a large degree. Okay, you can see that area there is vegetation. You can see it sort of mirrors the vegetation fairly accurately. You can see the river there in blue, which is fairly accurately as well. But you can see between the urban areas, it indicates a lot of bare soil. You can see that's the urban area. It actually indicates quite a lot of bare soil. You can see there as well, this is, I would think, more bare soil, and this is indicating some bare soil, but also some agriculture. You can see there is indications of, okay, it's still loading to some degree. You can see there is this vegetation, but there's some blue parts here as well, which indicates water bodies, and some red, which indicates urban areas, which there's for sure not much of that there. So you can see there are definitely some differences to be detected between, on this granular level. You can see the differences quite evidently between what the classification is predicting and what the actual classification should be. Now, as I said, the remedy to here is now to actually manipulate or edit these individual ROIs. Remember, we want ROIs or training samples that have specific spectral signatures for that specific class. So what typically happens here, you'll have a ROI, let's say a ROI for soil, okay, which have the same spectral signature as a ROI in urban. Okay, so that's what I mean when these ROIs within water should be not overlapping with any of these ROIs. So the spectral signature of the water ROIs should not have any similarities with the spectral signature of any of these ROIs. And that's why the placement of your ROI is so important. So let's have a look here. You can see, we go to this a little bit, that's where it's loaded. You can see, let's have a look, there's some, if you look at the LandSat, it indicates very little mountains, but if you look at the Sentinel, it indicates some mountains. You can see some mountains. Now that's typically would basically means that I have selected ROIs on the mountain that have actually vegetation. So I need to go and look at my mountain ROIs to make sure that I place them where it's only rock and not vegetation. Okay, so that's quite important. Let's look at the river. You can see with the Sentinel, you can clearly see the blue, which is river, whereas in the LandSat, it indicates either urban or mountains. You can see the difference. Okay, so we can play around with this, have a look, and as I said, what is then important is to, let's say, change your ROIs so that they are unique to that specific feature or class. And you can see, the differences between the two, and much more evidently when you use a split screen. You can look, for example, here on this side here, it indicates bare soil on the Sentinel, and on LandSat it indicates a mix of agriculture, a little bit of vegetation, some urban, which doesn't make any sense at all. Let's have a look at the map and see what actually is there. In fact, yeah, it looks like it's a mix anyway. Doesn't look like it's just yeah, doesn't look like it's just bare soil, as is what the center. Anyway, I think you're starting to get the picture. We can now play around with these numbers. Okay, and as I said, we can do the same for when we use the random forest method, and also you can put the any of the LandSat or Sentinel standard image versus the LandSat image, the standard versus the random forest classifications, and also then compare. Okay, so that's quite neat in that we can split screen these classifications, and you can actually visually compare to see whether there's similarity, where the similarities and differences are. Now, as I said, the interesting thing would now be to look at the similarities and keep them, and then where the differences is, to either convert the one to the other or vice versa in terms of the location. But my suggestion would be is to identify. So we have selected the, you see, we need to most probably move some of these rows. You see these rows, this blue one and that blue one for LandSat indicates mountain areas, whereas let's have a look at the map and see. You can see it's not really looking like a river. Now, this brings me to the other important point is between summer and winter. Okay. Now, in summer, obviously, the river will be much more sandy than in the winter. So you're going to get significant different classifications whether you use summer images or whether you use winter images. Okay. So that's going to be quite important as well. And as I said, you can see that the river actually looks more sandy than bluish, which could be a reason why. You can see if you were to put the spectral signature of the river here and the spectral signature of this area here, I don't think the spectral signature will be that different. Intuitively it would be the same. So that's why I'm saying that the key to accurate classification is the regions of interest of your classes, that 50 points and 58. Where you locate them is the key to a successful classification. Because bear in mind that many of these different features, they should have different spectral signatures, but in general, your big issue is bare soil and urban areas. They in many cases are very, very identical. So expect some issues. But anyway, yeah, so these overall accuracies statistically looks fairly good. I wouldn't be too sad about them. However, they can always be improved. Okay, thank you very much. I trust you enjoyed this video tutorial. Stay tuned for more action coming, and yeah, I appreciate you joining me on this journey of remote sensing, and I'll see you on the other side.